Hello, today I am going to teach you about the elementary operation of matrix, that is transformation. Okay, so first we will here see what is elementary operation and in how many ways we can do it. So first operation, first we will see that there are total number of 3 elementary operation in a matrix that can be done. Each matrix that 3 operations, each in row and in a column. It can be done in a row also or in a column also. So total 3 operations can be done. So first we will see first operation. What is first operation? So that is known as a swapping. Swapping means interchanging. So what it means that we will interchange 2 rows or a 2 columns. So in first operation we will do swapping, that interchanging of 2 rows or 2 column, that Ri will be replaced with Rj and Ci will be replaced with Cj. So now we will see how it can be done. So first we will do operation in A, that R1 will be replaced by R2. So here this is R1 and this is R2. So R1 will be replaced by R2 and R2 will be replaced by R1. So now the matrix, suppose that matrix is B, that will be equal to new matrix that will be formed after performing the swapping operation, that is interchanging R1 and R2. It will become, R1 will become R2, that is R1 we will replace it with R2 1 4 2 and R2 will be replaced by R1, that is 2 1 4 and R3 will remain as it is 1 5 3. Now similarly we can do a swapping in column operation also, that is C2 will be replaced with C3 and C3 is replaced with C2. Here what is C2? This is C2 and this is C3 and these both are interchanged, that this will go here and it will come here. Now we will suppose the new matrix is B dash will be equal to, no, we will replace it with only we will write it C, because B dash means transpose, so we can't take this. So suppose that matrix is D, it will be equal to, we have to write first column as it is because no operation is performed in that. So it will be 2 1 1 and next this C2 is replaced with C3. So it will come to be, it will become 4 2 3 and C3 is replaced with C2 and so it will become 1 4 5. So this is a swapping operation. As it is requirement of the question, we have to see what it will be beneficial for the reduction of a matrix. That operation we will do C2 will be replaced with C1 or C2 will be replaced with C3. Similarly C2 can be replaced, similarly C3 can be replaced. That depends on the type of question and requirement of the question. Next operation is multiplication of all the elements of any row or column by a non-zero number, that is any scalar value. A scalar value is multiplied. We will change the color. So what it is saying, that we have to multiply any row or any column with a constant and replace that row or column with that value. Suppose we have Ri, any row is replaced with Ri multiplied by any constant k. Similarly, Ci can be replaced with Ci multiplied by any constant, that is scalar value, where k is not equal to 0. So we will see how it is done in this matrix. So we will separate this like this. So what we have to do, what it is saying, that R1 will be replaced by 2R1. So we have to multiply this. This is R1 and this is multiplied by 2, and that value will be replaced in each element. So what that matrix will become, this is, suppose we take this is R B matrix, it is any B matrix because it is not A. So we will multiply R1 with 2 and replace all the elements. So first element 2 into 2, it will become 4, it will become 2 and it will become 8. Similarly, we are not doing any operation in R2 and R3, so they will remain same, 1 5 3. This is the new matrix after doing elementary operation. Now similarly we can do operation in column also, that is C2 will be replaced by 3C3. What is C2 here? This is C2 and that is replaced with 3C2. Means we have to multiply each element of C2 with 3 and replace C2 with that value. So any matrix that is D will be equal to this matrix. So first row will remain as it is, 2 1 1. Second matrix is C2 is replaced with 3C2. So first element will become 3. Second, 3 4s are 12. Third element will become 3 5s are 15. And last two will remain as it is, 4 2 3. This is second operation. Now we will see third operation. What is third operation? This operation says that addition or subtraction to the element of any row or column, the corresponding element of any other row or column multiplied by any non-zero number. So it is saying that as the requirement, if we want to reduce the matrix, this operation can be done in which we will replace any row. Suppose that row is Ri, we will replace that row with Ri plus k into Rj. Means Rj will be Rj, any other row will be multiplied by any constant, then it will be added or subtracted with the another row. Similarly we can do in column, any column can be replaced by any Ci. If any column is Ci, then that can be replaced with Ci plus constant is multiplied with another column and then it is added, and addition can be done or subtraction can be done as the requirement, how we want to reduce it. So suppose this is one matrix A. So now we have to do in this row operation. What it is showing, what we have to do, we have to replace R1 with R1 plus 2R2. So this is R1 and this is R2. So first we will multiply R2 with 2 and then we will add both these and replace it, add both this and replace R1 with this value. So suppose that matrix is B, new matrix formed is B. We will write here the transformed matrix. So what R1 will become? R1 will become R1 plus 2R2. So 2 plus 2, this will become 4. Similarly, next element 1 plus 8, it will come to be 9. Last element 4 plus 4, it is 8. Now next row will remain same, 1, 4, 2, and R3 will also remain same, 1, 5, 3. Similarly, we have to do operation in C2, that is C2 is replaced with C2 minus C3. So here this is C2 and this is C3. We have to replace C2 with C2 minus C3 value. Okay, so this is C2. So now if that matrix we call it D, it will become like this. So first column will remain same, that is 2, 1, 1. What second column will become? C2 minus C3 we have to do. So 1 minus 4, it will be minus 3. 4 minus 2, it will be 2. 5 minus 3, it will be 2. Now last column will remain at this is, that is 4, 2, 3. So these are the 3 operations which we have to do in finding the elementary operation of any matrix. By doing the elementary operation, we can find the inverse of a matrix. So these 3 operations we will be required to find the inverse of the matrix. So we will use all these 3 operations. Next, what it is saying that what is invertible matrix or inverse of a matrix. So for inverse of a matrix, A and B should be square matrix of order m. M means it can be 2, 3, 4, any order means m by n, 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. So and invertible, for invertible matrix, if AB is equals to BA, then that is equals to identity matrix. If this is satisfied, then B is called the inverse of A and it is denoted by A inverse, and A is called the inverse of matrix B and it is denoted by B inverse. A is said to be invertible only if A inverse exists. It can be said invertible only if there is A inverse exist for that matrix. And inverse of any square matrix, if it exists, will be is unique. So if suppose we have any matrix A and it has its inverse A inverse, and this is equal to A inverse is equals to B, and suppose C is also any matrix whose inverse is equals to A inverse, then B will be equal to C and these both will remain equal and unique and same. That's why it is called that if there is any matrix, square matrix, and if its inverse exists, then it is unique only. So here what it is saying, B is the inverse of A. B is inverse of A, so AB is equals to BA is equals to identity matrix. Now if C is also inverse of matrix, what I have said, then AC will be equal to CA will be equal to I. Then we can prove that B will be equal to C. Now see, B is equals to BI and we will replace BI with AC. Now we can write it like this, BA and multiplied by C. So this BA can be replaced with I, and I will be, if multiplied with any matrix, that will be equal to that same matrix. So here it comes to be B equal to C equal to A inverse. Now, invertible matrix. If A and B are invertible matrix of same order, then AB whole inverse will be equal to B inverse A inverse. Okay, this is satisfied. Now we will prove this. So for proving, we will take if AB is multiplied with AB whole inverse, that is equals to I, as we know the property that A is multiplied with A inverse will be equal to identity matrix. So this is first we have taken this, and we will multiply A inverse both side. Now when we open this, multiply this A inverse into A, B, and this will remain same, and A inverse I. So I is replaced, I can be removed. Now this is equals to what? I. So this will become IB into AB whole inverse is will be equal to A inverse. Now B multiplied, I can be removed. So B multiplied with AB whole inverse, here A inverse. Now we will here one step, we will multiply both side multiply with B inverse. So here we have multiplied both sides, then it will be equal. So B inverse into B, and this is AB whole inverse, and it will become B inverse A inverse. Now this is equals to I. Here we have written I, AB inverse, B inverse, A inverse. Now I can be replaced with, because identity matrix is if multiplied with any matrix, it is equals to that matrix only. So it will come to be AB whole inverse is equals to B inverse A inverse. So it is verified. Now invertible matrix or inverse of a matrix. To find inverse of any matrix, what we have to do? We have to do row or column operation. What it is said in a question, it is given that you have to find the inverse of a matrix by row operation or a column operation. If nothing is given, then you can use both or either of the two, in whichever you are comfortable. So for doing that, to obtain A inverse by elementary row operation, sequence of elementary row operation to be carried out on A is equals to IA till I is equals to BA, then B is equals to A inverse. So what it is saying, you will see this is row operation. So what is it is saying for row operation? First, what we have to write? We have to take A is equals to IA. Now this is a matrix A given to you. Now you have to perform in this row operation till it becomes I, identity matrix. And similar that operation, row operation, you have to do in I, and you don't need to touch this A, and you have to similar operation you have to do in this I, and that will be A inverse. So you will get A inverse by this. Similarly, if it is column operation, so in column operation you have to write like this: A equal to AI. So in this also you have to perform column operation, and in this column operation, and it will be remain untouched. So in this you have to do column operation till it becomes I, and when it will become I, then this will become A inverse. So like this we can find the inverse of a matrix. In coming question I will tell you how to do. Next, last, this is important to, sometimes we need to verify that if you know this property, this property of elementary operation, then you no need to do further question. So what it is saying, that after applying one or more elementary row or column operation on A is equals to IA, or if it is row, you have to, this is in row operation or in column operation. If there are all zeros in one or more rows or column of the matrix A on LHS, then A inverse does not exist. So if you want to do here row operation, suppose you are doing in this matrix row operation, so how you will write? You will write it like this: A is equals to this is IA. So okay, IA. So if you are doing row operation after, so what you will see? You will see that if you multiply this row with 2R1, then what it will become? 2 and 4. And then if you subtract that 2R1 with R2, then this row will become 0. So if one or more row are becoming 0, then we can say that no need to do further. Here we can conclude that A inverse does not exist. So similarly, in this matrix, if you are doing column operation, you will write it like A equal to AI. This is LHS and this is RHS. So if you are doing here column operation, and if you multiply here with 3, means C1, 3C1. So C1 is replaced with 3C1 minus C3. So what it will, this row will become, this column will, whole column will become 0. So we can say that the A inverse, B inverse of the matrix does not exist. And write here B only because it is given B matrix. Similarly, in this matrix also, if you are doing C is equals to CI, if you are performing column operation, then we see here that this matrix C2, if C2 is replaced with C2 minus 2C3, so it will become 0. So from first operation only we can conclude that its C inverse does not exist. No need to do subtraction also. You can, if two rows are equal or two columns are equal, then only you can say that their inverse does not exist. Because if two rows or two columns are equal, if any two row C2 is equal to C3, and if you perform an subtraction operation, then it will come 0. So if any row or any column are equal, then you can conclude that their inverse does not exist. So now what we will solve the question so that you can understand the all elementary operations. Here we are doing it with row operation. Okay, so this is the question: Row operation, what we have seen in row operation, we have to write like this: A matrix is equal to I identity matrix multiplied with A. Now we have to perform row operation both side. All whatever we are doing, we will do both side that operation. So let's write first here A. So what is A? A is 0 1 2 1 2 3 3 1 0, and that is equals to same order identity matrix. So it is 1 0 0 0 1 0 0 0 1, and A we have to write it like this. Same, we don't do any operation in this. So what it is saying, that we have to do a row operation till A becomes identity matrix. This A becomes identity matrix. So what is the requirement? That in diagonal we need all 1, and this upper triangular and lower triangular element should be 0. So we will do it, perform the row operation like this, that we will get this. So what we can do, we can, first operation is swapping. Okay, so swapping means interchanging. So first we will interchange. What we will interchange? We will interchange this R1 R2. So R1 is replaced with R2 and R2 will be replaced with R1. By this we will get first element 1. Our first aim is solve that in diagonal first element is 1. So we will do this. So what the matrix will become? It will become 1 2 3 0 1 2 3 1 0. Next, same operation we have to do in right hand side. So first row will become R2 will become R1 0 1 0, and R2 will become R1 1 0 0, and last row will be as it is, and A will be written like that only. Swapping, what we are swapping? We are interchanging R1 with R2. Next step. So here we have to write what we have find out in last. So then only we can do further. So first step, after interchanging we got here 1 2 3 0 1 2, and last is as it is 3 1 0, and this step here we got 0 1 0 and 1 0 0, this is 0 0 1, and A is multiplied. Now next step, what we will do, what we want to do, what we want to get, we want to make this, and here it is 0, so we want to make first this element and this element. We will go sequence wise. First we will make here 0, then we will go make here these three elements 0. So next we will what operation we will do? R3 will be replaced with R3 minus 3R1. So both sides we will perform same. So we will write this. First and second row we will write as it is 1 2 3 0 1 2. Now R3 minus 3R1. So 3 minus 3 is 0. 1 minus 6. 2 3 is 6. So 1 minus 6 will be minus 5. And 0 minus 9 is minus 9. So it is minus 9. Then here also we will do the same. So first and second row we will write as it is, 0 1 0 1 0 0. So 0 minus 0 is 0, 0 minus 3 is minus 3, and 0 minus 1 will be 0 minus 0. No, sorry, R3 means 0 minus, okay, and 1 minus 0 is 1, and we will write here A. Next step is R3 is replaced with R3 plus 5R2. Okay, now we will do this operation in this matrix. So R1 and R2 will be written same, 1 2 3 0 1 2 0 1 2. Last is R3 plus 5R2. So R3 plus 5R2, 0 plus 5R2. So 0 plus 0 will be here 0, and 0 minus 5 plus 5, this will become 0, minus 9 plus 10, it will make it 1. So we see here that all diagonal elements are 1 and these 3 elements are also 0. Now we have to take these 3 elements and as per the requirement we have to make these 3 0. Now similar operation we will perform this side. So what we have done, we will keep first and second same. So first row 0 1 0, second row 1 0 0, and third row. Now third row R3, 0 plus 5, this is 0, 0 plus, sorry, this is 0 plus 5, so it will become 5. Now next 0 plus R3, minus 3 plus 5 0, so it will become minus 3, and 1 plus 5R2, it is 1 only. Now next step, we'll go in next slide. So we have to write it again. So last what we got here 1 2 3 0 1 2 0 0 1, and this side what we got 0 1 0 1 0 0, and last 5 minus 3 and 1, and A will be written as it is. Next step, what we will do, we will do R2. Now we have to make these 3 elements 0. So we will perform this. R2 will be replaced with R2 minus 2R3. So this matrix will become, first row will be as it is, 1 2 3, second row R2 minus 2R3. So this will be 0 only, this will be 1, and it will become 2 minus 2 is 0, and last will be same operation we will do this side, right hand side. So this is 0 1 0 5 R2 will be replaced 1 minus 2 R3, 5 minus 10. So 1 minus 10, it will be minus 9. Similarly 0 minus 6, so minus minus, so it will become 6. Next 1 minus 0 minus 2, so it is minus 2. Last row will be as it is, 5 minus 3 and 1. This is 1. So A. Now we will do R1 is replaced with R1 minus 3 R3. R1 minus 3 R, this 3 R1, this R1 will be subtracted with this 3 R3. So it will become, R1 will become 0 0, so it will 1 2 and here 3 R3, so 3 minus 3 is here 0. So now 1 0 1 0, this is 0 0 1. Next here also same operation we have to do. Second, we'll separate it so that we can do next operation from here. So first R1 is subtracted with 3 R3. So 5 0 minus 15. 0 minus 15 will be, here comes minus 15. 1 minus 9, that will 9 will become plus 1, so it will come to be 10. Similarly this is 3, 0 minus 3, it is minus 3, and last two row will be same. First two, 5 minus 3 1, this is 1. Now next operation here we will do, what we will do, only one element is remaining, this we have to make it 0. So what we can do, we can replace R1 with R1 minus 2 R2. Now this side it will become 1 2 minus 2 is 0 0, this side 0 1 0 and 0 0 1, and similar operation we will perform here. Forget to write A you have to write in every step. Now this will, what we have done, R1 minus 2 R2, so similar operation we will perform in this side. So minus 15 plus 18, it will become to be 3 6. Now 10 minus 12 is minus 2. Minus 3 plus 4 is 1. Now these two will remain same, minus 6, minus 9, 6 and minus 2. This is 5 minus 3 and 1. So here we have seen that it has become I. If it has become I, then it is A inverse and A. So I is equal, this is one property, that I is equal to A inverse into A. So from here we find that value of A inverse is equal to, can write it here, 3 minus 2, 1 minus 9, 6 minus 2, 5 minus 3, 3, 1. So this is the A inverse. Hope you have understood this stepwise how we can do. Next we will do same question by column operation. So for column operation, what we have to write? We have to write it like this. A is equals to A I, means we have to write I. It is only notation because we are not doing any operation on A, so it will not make any change. Either we write it A here or here. Only for understanding that it is a column operation, we have taken this denotion. Okay, so now we will start. So we will write here A and we have to perform column operation. Column operation. So first we will write here A. What is A? A is 0, 1, 3, 1, 2, 1, 2, 3, 0. And here A is written as it is, and we will write here identity matrix of same order, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now first we will perform the operation, that is swapping, that is interchanging. So what we can interchange? We want here 1, in this place we want 1, so we can interchange C1 and C2. So C1 is replaced with C2 and C2 is replaced with C1. So what we will get here? We get here 1, 2, 1, 0, 1, 3 and 2, 3, 0. Last column is written as it is. Same step we have to do in right hand side also. So we will interchange C1 and C2. So first column will become 0, 1, 0 and this will become 1, 0, 0. Last is as it is. Next step, we have to write again for understanding, because we don't remember exactly what it is. So we will write here what we got in previous step. So in previous step, after interchanging, we got here 1, 2, 1, 0, 1, 3, 2, 3, 0, and here A is written as it is, and this is 0, 1, 0. It will come 1, 0, 0 and this is 0, 0, 1. Now next step we will do C3 is replaced with C3 minus 2 C1. So what is our aim? We have to make diagonal elements all 1 and this 3 elements 0 and upper 3 elements 0. So we will first make this 0 or this 0. So by doing this step, you are making this value 0. Minus 2, so this will become 0. So same operation you have to perform in right hand side also. So column 1 will remain same, column 2 will remain same. We have to perform in column 3. So C3 is replaced with C3 minus 2 C1. So C3 2 minus 2 C1, that is 2, it will come 0. 3 minus 4, it will become minus 1, and 0 minus 2, it will come to be minus 2. Similarly, same step we will perform in right hand side. 0 1 0 1 0 0, and this is 0 minus 0 will be 0, 0 minus 2 will be minus 2 here, and 1 minus 0 will be 1 only. Next step we will replace C3 with C2 plus C3. So this element will become, we have to make this element 0. So we will replace C3 with C2 plus C3. So it will come to be, first and second column will be same, 1 2 1 0 1 3, and this is we are adding, so this is 0, this will come 0, and this will come 1. Similarly, this side also we will do the same thing. So first and second column will remain same. So 0 1 0 1 0 0, and we will add these two column and replace it with C3. So 1 plus 0 is 1, 0 plus minus 2 is minus 2, and 0 plus 1 is 1. Next, further we need next step, so we will write previous again for understanding. So what we got here, we got 1 2 1 0 1 3 0 0 1, and right hand side what we got 0 1 0 1 0 0 1 minus 2 1. Now here we will do another step, we will replace C1 with C1 minus C3, and second step we will do, in one step only we can perform these two. C2 is replaced with C2 minus 3 C3, as we know that we want to make these three elements 0. So we will do C1 minus C3, so this will become 0. So what we get here, if we do C1 minus C3, so 1 2 and C1 minus C3, 1 minus 1 will become 0. Next we will write C2 here. Simultaneously we will do same process here also, so that we can't get confused. So what we did C1 minus C3, so 0 minus 1 is here minus 1, 1 minus of minus 2, it will become 3. Similarly 0 minus 1 is minus 1. Next column C2 is replaced with C2 minus 3C3. This is C3. So what it will come, 0 1 0, 3 minus 3, and last column will remain as it is. Next C2 is replaced with minus C2 minus 3C2. So C2 1 minus 3, 1 minus 3 is minus 2, 0 minus of 6, so it will come to be 6, and 0 minus 3 is minus 3, and last column will remain as it is, 1 minus 2 1. Now only one element is remaining that we want to make it 0. So here we can do C1 can be replaced with C1 minus 2C2. 2. So what it will come? It will come to be C1 minus 2C2. So 1 minus 0 is 1, 2 minus 2 is 0, 0 minus 0 is 0. This is same 1 0 0 0 1. So we got identity matrix here. Similar operation we will perform this side. What we did? C1 minus 2C2. So minus 1 minus of minus 4 minus of C1. So means C1 is replaced with minus 1 plus 4 is 3. Similarly, next step, 3 minus 12. 3 minus 12 is minus 9. Minus 1 minus minus plus 6. So it will become 5. This 2 will remain same. 6 minus 3 and 1 minus 2 and 1. So this is the inverse of A. So we can see that we got similar matrix by row operation and column operation. So this is I is equals to A into A inverse. So this is the value of A inverse. So A inverse is equals to, we write here 3 minus 9 5 minus 2 6 minus 3 1 minus 2 1. So what we can see? We can see that if we do column operation or if we do row operation, we will get same operation, same answer, because inverse is unique. So it will be same. So as per the requirement of the question, what it is said, what it has been said, that it has asked to find the inverse of a matrix by row operation or a column operation. You have to do like that. I have shown you both the method, and if it is given nothing, then you can perform both operations simultaneously. You can do row also, column also. You can do that both operation in same question also. It doesn't matter, only you need to get the A inverse. Thank you, and you can visit our website, this www.samatvaacademy.com, for the exercise, and their answers will be given, and you have to solve their questions and match with their answers. Thank you.